Hello everyone, my name is David and today I'm going to record this video that the black hole that kills the galaxies, quasars. The universe looks like a vast empty ocean sprinkled with the rare islands of galaxies. But this is an illusion. Just a small fraction of atoms are found in galaxies, while the rest is drifting between the intergalactic medium, like the roots of some massive tree, gas spreading from each galaxy, gravity funneling into fresh mass into dense cosmic forests. Here's the intergalactic medium, the raw materials of creations, hydrogen and helium, woven thus into sheets and filaments that flow into galaxies when they eventually create stars. But if we look close enough, we will see who's actually in charge. Quasars, the single most powerful objects in existence, as small grains of sand compared to the Amazon River that reside in the center of some galaxies, shining with the power of trillion stars, blasting out huge jets of matter, completely reshaping the cosmos around them. They're so powerful that they can kill a galaxy. What are they? How do they move within the structures of the universe at their whim? Everywhere you look, weird things in the sky. In the 1950s, astronomers noticed some mysterious loud radio waves coming from spots in the sky. They were named quasi-stellar radio sources or quasars because they were like dots and like stars. They were seen in radio waves rather than light. Everything about them was strange. Some flickered out emitted into high energy X-rays in addition to radio waves, but it seems to be tiny. They also move extremely fast, as much over 30% the speed of light. The only explanation was they must have been expanding so distant that their apparent speed was the actual expansion of the universe, moving them away from us. But these enormous distances meant that quasars couldn't be stars. They are active cores of galaxies billion light years away. It could get crazier. To appear so bright and loud, given these vast distances, they're 1,000 times brighter than the Milky Way. Monsters, exploding and screaming into the void with a violence that not thought possible before. As we mapped in the sky, we discovered over 1 million quasars. They were all seems to be very far away. Looking into space, far means very long ago because the light takes so long to reach us. Quasars were common in the early universe, having peaked in number 10 billion years ago when galaxies and universe itself was still very young. Let's go back in time, just 3 billion years after the Big Bang, and see what's going on after them. The incredible power of quasars. How could an early baby galaxy be so incredibly bright and violent? All light and radiation couldn't be stars. They were nearly enough of them. And since galaxies tend to grow in time by merging, the starlight from small galaxies shouldn't be farther bright any galaxies today. There's only one way to generate the vast amount of energy quasars shines with. Being supermassive black holes. We still don't know how they exactly formed, being super, but it seems that every galaxy has one in their center. But how can the brightest thing in the universe be black holes? We trap everything and anything that crosses their event horizon. Well, the light of quasars is not coming from inside the black holes. Rather, it comes from the space around them, a massive orbiting disk of gas called the acceleration disk. Quasars use the same field as stars to shine matter. It's just a black hole that they are the most efficient engines for the converting matter into energy in the universe. The energy released by matter falling into a black hole can be 60 times greater than the release of nuclear fusion in the core of stars, because the energy released from black holes comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up almost the speed of light before it crosses into the event horizon, causing the incredible amount of kinetic energy. Of course, once inside the black hole, it takes that energy with it. You only get to witness this energy if you drop your matter in the right way, fall straight down, and outside the universe get nothing. But when you have a lot of matter, it spirals incredibly fast towards the event horizon and forming a disk. Collisions between particles and frictions heat up to hundreds of thousands of degrees. And space is not much bigger than our solar system. The core of galaxies can be released many times more energy than its stars all combined. This is what a quasar is, a supermassive black hole having a feast. And these black holes eat a lot. Typical quasars consume to 100 Earth masses of gas per minute. 10 billion years ago, the universe was about a third of its current size. So intergalactic medium was less spread out, meaning the flaming gas around the quasars could feed them about a banquet, making them vomit insane amounts of light and radiation. The brightest quasars power jets tangling into the magnetic field of the matter around them into the narrow cone, like a particle accelerator that they launch enormous beams of matter out, flowing through the circumgalactic mediums, forming plumes of matter that grows to hundreds of thousands of light years in size. It's almost unfathomable in the scale, a tiny spot in a galaxy carving out patches of the universe 100,000 of light years long. But quasars couldn't eat for long, maybe a few million years, because their freeze ultimately kills their galaxies. How quasars kill galaxies. Maybe killing is a bit of exaggeration. A galaxy is still there after a quasar turns off, but it will never be the same again. Quasars, being among of the hottest and brightest things in the universe, break their galaxies by heating them too much and stopping a star formation. Hot gas cannot form stars. This sounds odd because in a hot cloud of gas that is already hot, atoms are moving really quickly. When they collide, they hit really hard, exerting pressures that resist gravity's squeeze, so hot gas can't form stars. Instead, the best gas for forming stars are already cold. They won't put up a fight when it's time to collapse into a star. On top of that, quasars put gas out of their galaxies. Not only does the quasar, but the galaxy loses the raw materials for new stars. As sad as this sounds, it may be a good thing for life. The alternative can be far more dangerous. Too many stars, new stars forming, usually followed by massive stars exploding in supernovae, so planets would be burned sterile. Of course, it's more complicated, like the intricate case of our own planet's biosphere. Every piece in the galaxy descended on influence every other part of the galactic environment, while hot things like quasars and supernovae tend to push gas out of the galaxy. Shockwaves and quasars just also compresses a gas, making new stars at least for a short time. And gas that leaves in general, we can say that without things becoming a little bit more chill, we would not exist today, which brings us to the final questions. Did the Milky Way have a quasars in the past? It's unclear if every galaxy went to a quasar phase, but the understanding distant quasars may provide clues to the stories of history of Milky Way. Galaxies don't do a good job of preserving their history, like sand on the beach on the endless turning mixes waves with the clues to their past. It's possible the Milky Way was once a quasar, which allowed supermassive black holes Centaurus A to have grown to 4 million times the mass of our sun, and that dormant is now Centaurus A star could turn into a quasar in the future. In a few billion years, the Milky Way will merge with the Andromeda. We've seen over 100 double quasars and galaxies smashing together, where fresh gas is provided for central black holes. But it won't last for long. When galaxies merge, so do their supermassive black holes, shrinking into the center of their new galaxy, casting nuts and stars in every direction. We don't know whether this will happen, but it will be a truly incredible sight. Maybe some beings in the future are going to see and witnesses in awe of what they see. So that's the end of the video, and I hope you enjoy it. Goodbye.